just repeat a little bit. So we are starting 9.1. We are factoring numerators and denominators of polynomials. So if you look here, you can see some examples of rational expressions. That's what these are, where you have a polynomial on top and bottom. We're going to factor the numerator, factor the denominator, and then cancel any matching factors. So I told you guys yesterday that one of the most important skills that you'll learn in any algebra class that you need for any math class is factoring. You have to be able to factor. It's a part of lots of different types of problems, especially as you move up after Algebra 2, okay? So it's one of those skills, it's just worth knowing really well. Don't just be like, oh, I'll just not do so well in this next quiz and I'll be okay. This whole chapter, chapter 9, is factoring, okay? All right, so let's start. Even if you're still writing these, make sure you have this on your paper, okay? So you're not like writing while I'm teaching that. I'll give you time to write these down, okay? So I want to make sure everybody's together right here so I don't lose anybody. Okay. Let's just start with that. Less overwhelming when you see it like that. Okay, so you're going to look at your numerator and look at your denominator as two separate problems in the beginning. So you look at your numerator, and after our review yesterday, I'm hoping you recognize that as the difference of squares. And when we have the difference of squares to factor it, we have two parentheses with two different signs. It doesn't matter if you have the plus or the minus first, because everything else in the parentheses is identical. We do the square root of x squared. See how it's in the first spot? It goes in the first spot of these parentheses. And then the square root of 36, 6, and 6. Okay, so that's factored. The numerator is factored. Okay, the denominator, this is one of our chart problems. It's a quadratic trinomial. Okay, and this is the easier chart problem. I know it's the easier one, the shorter one, because there's a 1 in front. We like it when we get one like this. Okay, so I'm going to make my little chart. And this is optional. I mean, if you can do it in your head, that's fine too. What two numbers multiply and, sorry, this is multiply and this is add, sorry. So what two numbers multiply to get A times C? So 1 times negative 66 is negative 66. And B value is negative 5. And there's no shame in your game picking up your calculator and trying different numbers. 66 stands out to me because it's double digits of the same number, so I know it's divisible by what number? You remember? 11, right, Mandy? Good. So 11 times 6 is 66. Makes sense. And if you subtract 11 and 6, you get 5. So I always start with writing the numbers, 11 times 6 and 11 plus 6. Now we know that's not the final answer, right? We need to get a negative 5 over here. So one of these numbers, 11 or 6, has to be negative to get a negative 5. Which one? 11. So negative 11 plus 6 is negative 5, yay. Make sure it's the same over here. Negative 11 times 6 is negative 66. Sorry, it's so small, I'm kind of squeezing in there. Okay, so once you find your two numbers and we realize it's the shorter method, because it's a 1 in front, we go right to x minus 11, x plus 6. Guys, the order of the parentheses, I'm going to keep saying it because that's a question I get a lot, so I know some of you are like, why does she keep saying it? The order of the parentheses does not matter as long as the 11 is negative and the 6 is positive. Okay, same thing up here. It doesn't matter which parentheses goes first. What should happen now, because I'm not going to give you any that are to trick you or anything like that. That's not my deal. You should be able to cancel identical twins. When I say identical twins, I mean identical. All the numbers, letters, and signs are the same. So hopefully you see that this x plus 6 and this x plus 6 cancel. And all that's left is x minus 6 over x minus 11. And that is your final answer. We can't cancel these x's, okay, because they're tied to a number with a plus or a minus. By the way, if it was like a 6x over 11x, no pluses or minuses, you could simplify that. The x's would cancel and you'd be left with 6 over 11. But you can't when there's pluses or minuses. Okay? All right, let's try the next one. Take a second and write that down if you haven't already. So 2x to the third minus 6x squared over x to the fourth on the outside of the parentheses of this chart problem, x squared minus 4x plus 3. Lots going on there, right? But don't get overwhelmed by looking at the whole problem. Piece by piece is what we're going to do. So look at your numerator. Use your notes from yesterday until you feel comfortable. But that's a GCF problem. They have something in common that we can factor out. Look at the numbers. They both have a 2 in common. So I'm going to factor a 2 out of the numerator. And remember, with variables, you take the smaller number. $3, $2, what can they both contribute? $2. So you always take the smaller number of variables. Whatever's left over after you take that away is what goes in the parentheses. So this was a 2 with 3 x's. We took the 2 and 2 of the x's. There's 1 x left, right? X to the first. 6 divided by 2 is 3. And we already took away the 2 x's. So this is a good chance right here, not writing it out, just in your head, just doing a quick distributive property. 2x squared times x, I should get 2x to the third, and I do. 2x squared times negative 3, I should get negative 6x squared, and I do. Okay? So my numerator is factored. In my denominator, I have an x to the fourth. I'm not doing anything with that yet. And I recognize this guy as the same type of problem as we just did, just different numbers. So this is a chart problem with the shortcut method because there's a 1 in front of it. So in a minute, I know I'm going to have 2 parentheses here. So I'm just getting it set up. Okay. So what's going to go in there? Let's play with that. All right. I am running out of space. How much room do I have here? All right. I'm going to try and squeeze it in here. So I'm going to make my little chart. Let me zoom in so you can see it. So 1 times 3 goes here, and negative 4 goes here. So when you're coming up with the numbers, again, don't worry about signs. Just think numbers. So there's only 2 numbers that multiply to get 3. It's a prime number, 1 and 3. So somehow it's got to work. I'm not going to give you one that you can't factor. I'm not here to trick you. So 1 times 3 is 3, and 1 plus 3 is 4. But I need to make it a negative 4. So I'm going to mess with the signs. What can I do to the 1 and or the 3 to get a negative 4? Both negative. If you make this negative and this negative, you get negative 4. Negative 1 plus negative 3 is negative 4. Now make sure it's good over here. Negative 1 times negative 3, is that positive 3? Yes. So there's our numbers, x minus 1, x minus 3. Any order. The minus 3 could go first, or the minus 1 could go first. Now we're ready to simplify. It's all factored. So to simplify this, there's one real obvious one, right? X minus 3 cancels with x minus 3. So we know for sure we're going to have an x minus 1 in our denominator. But there's something we can do here as well. Like this is a 2 over 1. We can't really simplify that, right? The 2 and the 1 that's understood there are just part of the problem. But what about the x to the second over the x to the fourth? Understand what that means. There's 2 x's on top and there's 4 on the bottom. That's what that means. So when you simplify x to the second over x to the fourth, we can cancel one of those with one of those and one of those with one of those. We have nothing left on top, but we have x squared left on the bottom. Okay? So another way of looking at this is 2 minus 4, or 4 minus 2, however you want to look at it. But since the bigger number's in the denominator, that's where it goes. So there's a 2 on top, right? That's that 2. And then x to the second over x to the fourth is the x to the second. We canceled the x minus 3's, and then we would have x minus 1 also in the denominator. Okay? So if the x to the fourth had been on top, then in our final answer, x to the squared would be on top. Wherever the bigger number is, that's where your answer is going to go. Okay? So the hard part of this is not the actual new material of canceling stuff. That's not difficult. It's remembering how to factor. So that's where I worry about you guys the most. So that's why we did a day of review, and there's a video, so you can go back and review it if you need to. Last one, and then I will tell you your homework. So I have a numerator, and I have a denominator, and I need to factor both. By the way, you could get one of the halves that doesn't need to be factored. You could have just like 5 on top, just the number 5, and maybe you only have to factor the denominator, okay? So sometimes only 1/2 of your fraction needs any work. I'm giving us 3 examples here where the top and the bottom do. All right, so in my numerator, that would be a GCF problem. Notice they have stuff in common, okay? They have a 4 in common, and how many B's? 2. What's left over would be B plus what? What's going to go there? 1, okay? If you need, let me write it off to the side because I don't really have room. But if you were confused by that, let me just show it to you with a little more work. So we decided that 4b squared was our GCF. So what I'm doing is dividing each of these by 4b squared. Okay, so the 4's cancel. There's 3 on top, 2 on the bottom. That leaves us with 1. And then identical twin on the top and bottom, just like 4 over 4 would be 1. 4b squared over 4b squared is also 1. So if you needed to show that step, you could. All right, and here is our last type of factoring, which is the longer method chart. Okay, this is a 3 in front. It's a 3b squared plus b minus 2. So it's a quadratic trinomial, but when there's a coefficient at the beginning, a leading coefficient that's not 1, we have to do the method where we bring down the outside 2 and split the middle. So I'm going to use this space right here to do that. But let's start out first with our chart. We need to find those 2 numbers that we're going to split the middle into. So again, we do A times C is -6, and our B value is 1, right? That's a 1 in front of the B. So 6 has 2 sets of factors, 1 times 6 and 2 times 3. Only one of those sets is going to give us a 1 somehow, and that would be the 2 and the 3, right? So 2 times 3, 2 plus 3. We want to get a 1 here. Let's mess with the negatives. Which one will be negative to get a positive 1? -2, right. Make sure it works over here, and it does. So -2 times 3 is -6. -2 plus 3 is 1. Now, because of the 3, I don't get to just go make my 2 parentheses here. I have to bring down the outside 2 terms and split the middle into these 2. So I would have 3b squared and -2 come straight down, and then these 2 go in the middle, but don't forget to give them that variable. If one of them's negative, even though it doesn't matter, it is easier to put the negative first. Then we do our parentheses. And we're doing the GCF thing again. These 2 have in common a B. And guys, there's nothing that 3B and 2 have in common other than what? What do everybody have in common? 1. We have to put something there. Even if it's just a 1, we have to put something there. And notice our parentheses are the same. That's what they're supposed to be. If we did it right, and we did, the parentheses are identical twins. And our factored answer would be what you see in parentheses is 1 set of parentheses, doesn't matter which one, and the GCFs, the B plus 1. That's why you have to put something there. Because what would you put here? B what? So even if it's a 1, we put a 1 there. So that's our denominator. 3b minus 2, b plus 1. hopefully you see b plus 1's cancel, and we're left with 4b squared on top over 3b minus 2 on the bottom. And you cannot simplify this because of the minus. You can't, like, think of the minus, the plus as like the glue that holds those two terms together. You can only cancel them if they're identical with what's in the numerator. Okay? So, I saw a lot of you guys ripping out your page. Good job, good job. I will get you started. We're on page 121. If you didn't rip it out and you need to, go ahead, or you can kind of use my paper. You definitely don't have enough room, in my opinion, to write on here. Maybe if you're really, really write small and you're a really, really good factor, you can write on here. Y'all know I can't fit on there, so I'm going to write on another piece of paper. Okay, so bonus in this one, bonus in number 1, anybody know why I'm saying that? What about number 1 is making me really happy? Yeah, that's true. That makes me happy. But something else. What's the numerator? It's already factored, right, Mandy? Thank you. It's already factored for us. Okay, we'll take it. All we have to do then is our denominator. That, recognize it, that's a chart problem with a 1 in front. So 1 times negative 12 is negative 12. B is 1. So 12 has quite a few factors. Don't write all this out if you don't want to, but you're looking at potentially that being the two numbers, those two being the numbers, or these two being the numbers. It's got to be one of those, but only one of those will make a 1, right? So that would be the 3 and the 4. But this is your workspace. It's okay to write things down and cross it out. That's what it's for. Now, 3 plus 4 is certainly not 1, so we know we got to mess with the signs. The 3 would be negative. Good. Yep, negative 3 plus 4 gives me 1, and negative 3 times 4 gives me negative 12. Remember, what's written over here has to match exactly. So my numerator is done for me. Thank you very much. Denominator, we now have that. X plus 4 and x minus 3 in any order. And then find your identical twins and cancel them. Evan, come on, you should be doing this. We're doing homework right now. And that's as far as we can go. That's all we could cancel. All right, I'm not being very aware today. Sorry about that. I'm going to do number 2 with you because I'm just so sweet. And then I will let you do the last 3 on your own. Yep. Yeah. Okay, in this problem, the denominator is already factored for us. So all we have to factor is this guy right here. That is a quadratic trinomial chart problem. Shortcut method, again, because the 1 in front. So 1 times 2 is 2. B value is 3. 2 is a prime number. There's only 2 numbers that multiply to get 2, 1 and 2. And luckily, they also add to get 3. When everything's positive in the quadratic, both your numbers are positive. It'll always work out like that. Okay, so we have y squared, y plus 1, y plus 2, over 2y. I'm just rewriting my denominator. and then looking for things to cancel. For sure, we're going to cancel those. These two binomials can't be canceled, right? Y plus 1, y minus 4. But we can simplify this. This is a 1/2. That's not going to get simplified, okay? 1/2 is 1/2. We're going to have this 2 in the denominator. But you can simplify. You have 2 y's on top, 1 on the bottom. Cancel 1 or 1. You're left with 1 on top. So you have y times y plus 1. That's what's left in your numerator. And in your denominator, you have a 2 and then a y minus 4. Okay? Now I'm going to put the last few up. The answers are there, not the work. You need to do the work. Okay? So you're doing 1 through 5. Not 6. You did 1 and 2 together. You're going to do 3, 4, and 5. Remember, these are the answers, not the work. Thanks. Do you want to see the notes? I think you're good at that. Yeah. No? You get A's on everything. All right, you ready? More of a... Yeah. It's on Brian's desk. Did you get it? It's. Can you just give that to her real quick? She should take a picture. Thank you. So I'm going to do this.